Hello, I'm Michael Schulman from Supermicro, and today we have an exciting webinar for you. Welcome, and what we're going to do today is explore the latest innovation in data centers, the integration of AI factories, and advanced grid management technologies. The session will let you know and provide insights into these emerging technologies and strategies for shaping the future of compute and energy management, which is very intertwined these days. I want to call out one thing before we get started. There is an attachments tab where you can download some of the attachments from today's presentation, and there is a Q&A button. Please enter your questions in the Q&A area, and we will get to them. So let me introduce my guest today. First, I have Kevin Kulp, the product lead for Supermicro's SuperCloud Composer, and Bob Davidoff, the CEO of Bentos. Okay, this is our agenda for today. We're going to talk about data centers and AI factory concepts, grid management in this new age of high performance computing and AI, and the synergies and future trends in data center, AI, and factory management and grid management. So we're going to go through these, and we'll have Q&A at the end. So Kevin, tell us a little bit about Supermicro.
Thanks again, Michael, for having me. I'm so excited to be here with Bob and Bentos and really showing what we're doing here in grid management and energy management. I'd like to focus today on really what Supermicro is about. We've evolved as a tier 1 provider. We started as a component-based company, evolved into building servers and then building racks at scale, and those being liquid-cooled racks, and then into a complete liquid-cooled data center building block solution. And so I'm happy to be here with Bob presenting on this important topic.
Okay, great, Kevin. Thanks a lot. Okay, Bob, tell us a little bit about what Bentos does. Who are you? What do you actually do?
Michael, it's also a pleasure to be here with yourself and Kevin Kulp. We were talking a little bit before on how we were talking about things started with the grid, and then it moved over to the cloud, and then now over to a neo cloud. I like to say that the grid's making a comeback. So with that being said, what we do is we integrate into the ISO markets. We have a lot of energy orchestration. Part of that, the main topic, or one of the main topics today, is energy. So energy orchestration and grid management, and to really bring all that energy data into the DSIM world and into the rack. So really a pleasure being here today.
Okay, great, Bob. Thank you very much. Okay, Kevin, why don't we talk a little bit about, data centers have changed. What's old, what's new, and why is this so important that we look to so many new technologies? What's going on?
We see here at Supermicro, modern data centers are evolving into sustainable AI factories where compute becomes dynamically scalable, distributed, and power intensive. Data centers in the past lacked any kind of sensor data collection and true observability. PUE, thermal, power optimization are in every DevOps administrator's mind these days.
Okay, great. So as we move, what is Supermicro doing about, this new era of data centers and AI?
Supermicro is addressing this head-on by building an ecosystem of a vertically integrated software stack of Composer, Orchestrator, Director, and Developer Console. This emergence of neo clouds is driving this demand for a unified tool set. Time to align for data center deployments is becoming the key business KPI.
Okay, but a data center is more than just hardware. What's so critical about putting software that manages the entire data center together?
At Supermicro here, I lead the strategy behind SuperCloud Composer. Our platform is built on an open standards architecture through a unified data center management control. SCC simplifies the growing complexities of GPU racks, liquid cooling, and heterogeneous compute at hyperscale. Today's data centers need full visibility from node to cluster to facility, and SCC is answering that challenge.
Okay, great, thank you. Bob, so with your software, kind of explain what it does, what the flow is, what the problem that is being solved.
Sure. Thank you, Michael. I think we can sum it up in one macro word, and that problem is energy. As we know, data centers, one of the biggest problems out there is power procurement, energy management, and actually even more energy orchestration. So what we've developed over the course of the last 4 or 5 years is what we call POW, which is our Power Asset Orchestrator. And this slide here really sums it up pretty well. So on the left-hand side, you can see wind, solar, battery, and gas. Let's just say those are all power assets. And then we bring in on-prem. There's an emergence and a trend that we can see that people are moving hybrid and moving back on-prem. And with that being said, there's a lot of IoT and telemetry data that we use. So now we are orchestrating these power assets in real time. And with that being said, that middle part of that slide, for all us IT guys out there, that's a typical data pipeline. So what we're doing is, for the first time, we're bringing in grid data, real metadata that's coming in, such as real-time energy pricing. And then we're working with Kevin's team with Super Cloud Composer with the API endpoints to now bring, for the first time, not just observability and sight, but we can really do business rules and have AI agents basically managing these power assets. And then we're working really closely with grid structures, and now we're revving up and ramping down GPU workloads.
Okay, great. Okay, yeah, very interesting concept there. So Kevin, and Bob, why do we need visibilities into these AI factories?
Well, Michael, really data centers' biggest operational faux pas was observability. Most data centers today are flying blind. Even a recent discussion with a hyperscaler CTO admits this oversight. I can't imagine today getting in your car and not having any kind of instrumentation to operate your vehicle safely and efficiently. Data centers grew in complexity, but DSIM tools did not. SCC is designed to replace this fragmented application sprawl that exists in the infrastructure. Operators are still relying on SNMP, parcel metrics, and telemetry collection. And systems were never designed for GPU workloads to move to the public cloud. Data center enterprise operators now are looking for more on-prem solutions because of sovereign AI initiatives.
Okay, great. So
It's very important visibility into your entire AI factory. Okay, so there was the old way of doing things and the new way of doing things. What is so different about this?
Really, Michael, APIs need to scale. In SCC, we see the move from static enterprise workloads to dynamic AI workloads. AI factories require automation and scalable GPU infrastructure. Supermicro's ambitious data center building block solution design brings to market a unique value proposition, unified data center experience supporting important milestones of time to online service, vertically integrated software stack, and a cutting-edge liquid cooling infrastructure to optimize critical AI workloads. If you look at traditional data centers in the past, workloads were predictable, CPU-heavy, steady state, low volatility. And yet, most tools still treat these systems like slow-moving enterprise clusters. SCC was built on this change movement and management to automate lifecycle operation, provision, scale, and monitor across thousands of GPUs. An AI factory is a massive GPU clusters, parallel training pipelines, elastic scaling, and liquid cooling. Hardware-level telemetry needs to be exposed in APIs rather than Modbus, SCADA, or SNMP-based protocols of the past. Super Cloud Composer is built to use Redfish natively. Supermicro exposes some of the richest Redfish schemas in the industry. Redfish gives us a fine-grained control for power rails, power shelf, GPU temperature, PSU draw, fan speed, and many more important metadata used for data center operations.
Okay, great. Thank you. Okay, Bob. So as we look at the convergence, like you've been talking about power, thermal, AI, what is so important? What do people need to remember as they build out their data centers?
Yeah, as we're moving over to Kevin's point on the difference of data centers moving over to AI factories, there's large differences. First of all, the density is increasing and the power side. With that being said, the thermal, which is the heat of those machines and that compute, we're starting to be able to manage that. And then last but not least, and this is now, again, bringing in the grid management and the energy data inside for the first time to make workload decisions. So with that being said, we do want to have reference architecture. We want to use a standard schema such as Redfish. To Kevin's point is that an SNMP and Modbus, there's as those technologies are old, some of the newer trends in there as we move over to something like Redfish is we really want to solve for a latency issue and then also a security issue. So, as much as we're bringing in over this grid management and this energy data, we don't want to forget the roots, which is security and low latency, and that's what we're bringing to the table.
Okay, can you define, here on this slide, what DR and FR is?
Yeah, Michael, that's a great question. And this comes from our energy expertise. And this is bringing not only just the energy data, but also the energy strategies. So for example, as people are out there procuring and building these new data centers, part of the utilities, one of the first questions that they're coming out with and saying is, what's your curtailment strategy? And then what's your programs? So with that being said, and this was new to us, we talked a little bit about our crypto background years ago, but we didn't know that these programs existed in the energy markets. And now we're bringing those same programs into AI today. So DR stands for demand response and FR stands for frequency response. And those are ancillary services by tying into the grid and now being a good steward where we're now can flex load and work with the utilities. For example, a demand response, an event on that would say a big storm happened and now there needs to be a signal out there for curtailment. So what will happen is that a CSP, they're called a curtailment service provider, would work in that previous slide with an ISO. Those are the independent system operators. We would get this signal. And since these large consumers, we're talking about gigawatt factories here, that's 1,000 megawatts. So when you have that kind of load, part of this is that there might be a time of need for a community to say we need more power. So with that, we'd get a signal to say, you guys need to curtail or shed load. And this is in our industry, this is truly saying that we can add grid resiliency, being a flexible load. And so these are some of the programs that we actually now can participate in, and then really bringing that insight and value to the AI factories to say, hey, look, we can integrate DR programs and FR program in today's AI factories.
Okay, that's great. That also makes sure that the systems, if necessary, shut down properly.
That's correct. And so, because one of the things, and here's a lot of people don't get this, and it's just lessons learned on our part too, is let's say that there's a large stress on the grid and pulling a lot of power. Okay, that can lead to a blackout. So then there'll be a signal to go and say, oh, we need to shed or we need to basically curtail that load. But you know what? On the flip side, if the grid's generating too much power, the same thing can happen. So there's truly a balancing act there where basically I always say this tug of war with this red flag in there and just moving back. So when you're talking about flexible load and grid balancing and grid resiliency, those are all the new insights. And then we're really happy to work with Supermicro and Kevin's team to bring all that data and then truly, really now become a flexible load.
Okay, it really all has to be integrated. I mean, that's the key, right? Integrate the data center with the power.
So, and this is where we see what your guys' vision is, your data center building block solutions, is that everything is not just siloed into a rack. And then now it's moving over into what we call the digital infrastructure, but it doesn't even stop there. You also now need to move over to the grid and then now into the grid management and look at those services. And then when you put it all together, to your point, now we have a complete ecosystem.
Yeah, very important moving forward. Very important. Okay. So you talked about this flexible load. So Kevin or Bob, can you address, how these AI factories are so different than previous? We covered a few of these points, but anything else you want to cover right here?
Yeah, I mean, really, Bentos and Bob's team are bringing some tremendous IP and tremendous technology into our focus on data center building block. And as I mentioned before, that is our initiative now to really build out data centers to provide that level of service for time online when you're looking at data center operators. It takes time. There's discussions about curtailment strategies. There's different discussions of what type of optimization can you bring to the data center. And Bob's team is bringing that important aspect into our whole solution and providing, as Bob had indicated, a true digital infrastructure is unified, right? No fragmentation of tool sets. It's all unified, and data center operators are ready to go. They're ready to take this to and bring new heights into the industry here in your data center.
Okay, Bob, what do you mean here by virtual batteries?
Yeah, so virtual batteries, it's interesting, and this goes back to our crypto background, and then even on the energy side, is that there's things called like a VPP. Those are virtual power plants. So when you're truly, I like to consider it, and a word out there is that I call them GPU flywheels. So a GPU flywheel is something where now you have these AI factories that's loaded with GPU compute. And so now when you basically have all this power from the grid, and now you have a substation and all these electrons, whether there's surplus or let's say that the grid is getting taxed, as a virtual battery, we can rev up and ramp down and really treat energy as a reserve. So basically compute is turning into a virtual battery that is now commodity driven. So we have energy going into computations, and that computation there, you can look at it in terms of now becoming a virtual battery.
Okay, very, very cool. Okay. So together, with our companies combined, Bob, what does PAO deliver for the data center operator?
Yeah, so part of this and integrating into Super Cloud Composer, our POW, what we call our Power Asset Orchestrator, is really taking in DSIM world, having rack data to now bring that insight and bring it into that ecosystem and vertically integrating all that grid data, real-time energy data coming in, and then looking at how to bring that in to Kevin's point and your point, really a unified dashboard, because right now there really isn't unification, data scattered here, data scattered there. And then for the first time, I'll even give a great use case out here. So right now, a lot of the AI factories and a lot of the training and the inference is looking at how to lower their token pricing. And so your number one expense in a data center, especially when these talks about gigawatt factories, that's 1,000 megawatts. I think people still don't realize that the just tremendous amount of power that is. So when you can shave or you can create efficiency down to your number one expense, which is energy, and even shaving down 1 penny just to put it in scale on a gigawatt factory, let's say that that's 1,000 megawatts, you're talking about $8 million per month on every 1 penny that you're saving. So when we can bring insight, and then when we can orchestrate and flex load, and we can look at shaving off 1, 2, 3 cents, you're talking about $20-30 million a month in cost savings.
Yeah, wow. I didn't know that. Okay. Okay, so in conclusion, Kevin, how does this all, work together and work with Supermicro's vision?
Yeah, thanks a lot. So we'll definitely talk about from a data center perspective. I'll let Bob touch on really what some of the futures are and what he's looking at from a standpoint in bringing that good IP and technology into Supermicro to provide this whole data center building block solution. But I want to touch on one thing that is important, and some of the folks maybe in the industry as far as data center operators are missing this, right? We have some players and technology partners that are really focused on the infrastructure, right? Cooling, power optimization, and energy, but they really fail to have visibility into the data center, right? They really don't have rack level management. They don't have pod view to show, where servers are allocated into particular racks and bring out, telemetry associated with power and all of this, right? And so a lot of that stuff is siloed, like Bob was indicating. And so then you have the data centers that are relying on DSIM, data center integrated management, to provide in their data center operations. And they have the full visibility into the data center, but they lack any of the infrastructure, right? As far as what we're doing for our turnkey solution for liquid cooled data centers. So we're bringing this all together in a unified dashboard experience, as Bob had indicated. And it's a game changer in the industry, a true game changer in the industry. And we're excited to be part of this and really leading the charge and being the leading market provider in the market.
Okay, great. So Bob, some closing thoughts from you on, this whole integration and how we're working together.
Yeah, I think just to reemphasize, energy and power really is that number one topic. And before, ignorance was bliss a little bit in terms of power was just given to data centers. When you're starting to move on to these bigger loads, you need innovative software and technology. The stuff that we're working with SuperCloud Composer and ourselves is now to have that true convergence of there. So smart grid management is going to continue to be there. There's going to be a lot of innovation that will continue. The other thing that to bring out there, as we see in the trends in the industry, density. It reminds me of how small can something get. Just an Apple iPhone, for example, would start here and then get smaller, smaller, smaller. We're seeing that with the density of compute. So we're looking at, which is amazing to me. I like to point out a doorway. A lot of people know the size of a doorway. Like, can you imagine the size of that doorway to have 1.2 megawatts of just power inside that rack? And there's securities that we need to look at. There's vulnerabilities that we need to look at. So it's great that we're moving into that new world of dense compute. Now there's thermal problems, and so this is now where our teams together come in with the solution mind. Is like, yes, we're moving, we're going into those trends, then to provide the solutions to make sure that we get there.
Okay, great. Okay, so that was we have a question here. Someone's asked about SuperCloud Composer, that they've heard of it. This is for Kevin. Can you just give an overall quick summary of some of the capabilities of SuperCloud Composer and why it's so important in this next generation data center?
Yeah, great. Thanks for bringing this topic up, because it's very important of really getting oversight and observability in your data center, everything from day 0 through day 2 operation. So day 0 would be provisioning and deploying an operating system and being able to prepare it to put out critical workloads, AI workloads. And it's a software defined approach here. And then moving into really the operational piece of collecting telemetry and analytics in order to make those data-driven decisions. And with Bob's team of bringing in the grid management and allowing DevOps administrators to make those data-driven decisions is very, very important. Because when you get a blip in energy as far as power, your LLM models are toasted, right? And you have to start all over again, right? So these critical AIs are becoming more and more important, building high availability into the data center, having these critical telemetry and analytics real time for those DevOps administrators to make those data-driven decisions are very, very important today in the industry.
Okay, great. And a question came in for you, Bob. They said nuclear power reactors. So I assume what they mean is, we've heard some data centers building a power plant on their site. So how does your software work with that?
Yeah, so nuclear, it's funny that's becoming a hot topic. There's building right now in Texas, and nuclear is starting to come in and just as gas. So that slideshow back when we saw the solar, the wind, the batteries, just picture also having nuclear there. So that's a power generation. So that's a power asset or power generation. So what we can do, powers, at the end of the day, however it's generated, it'll still go through a line and then the transmission and distribution. So that's when we can literally lasso that power and then work with the curtailment providers. We can work with the ISOs out there to then bring that power in and help manage it.
Okay, great. Okay, well, thank you very much. So that's all the questions we had, but we're open to more questions. Click on the Q&A and we will get back to you. I want to thank everyone. Remember, you can download a couple of our white papers and data sheets from the attachments tab, and then get in touch with Supermicro through your sales rep or through our website. Ask about SuperCloud Compose or ask about data center building block solutions, and we will get back to you very, very quickly. Okay. Well, thank you everyone for joining today and have a great day. Okay. Thank you.